Hi students, welcome to NADAR'S Voice YouTube channel. Students, last class we discussed the equations of motion. In this class we are going to discuss motion of a freely falling body. Students, in this class we are going to derive the equation for motion of freely falling body. To understand this concept, first you need to know what is meant by free fall. When all these objects are dropped in the absence of air medium, that is vacuum, all would have reached the ground at the same time. Students, when the objects are dropped from certain height in vacuum, that is absence of air medium, here all the objects have reached the ground at the same time. The type of motion is called free fall. A freely falling body is moving under the acceleration due to gravity. There is no air resistance, so a freely falling body is moving under the acceleration due to gravity. Since the acceleration due to gravity is constant, the body will be accelerated uniformly. Okay, the acceleration due to gravity is constant, so all the bodies moving under the gravity, so the acceleration of the body is uniform. So the acceleration due to gravity is constant, the body will be accelerated uniformly. Thus we can say that a freely falling body is having a uniformly accelerated motion. From the concept we can say that a freely falling body is having a uniformly accelerated motion. Students, you can understand this concept by using this activity. Take a large stone and a small eraser. Stand on the top of a table and drop them simultaneously from the same height. Students, we consider the mass of the stone and the eraser both are same. It is dropped from certain height simultaneously. Okay, so what do you observe? Next, we take a small eraser and a sheet of paper, drop them simultaneously from the same height. What do you observe? This time we take two sheets of paper having same mass and crumple one of the sheets into ball. We take two sheets, one sheet is crumpled into the ball shape. Now drop the sheet and the ball from the same height. What you observe? Okay, so there is 3 experiments. So from the activity 4, you can observe that both the stone and the eraser reaches the surface of the earth almost at the same time. From the first, okay, we take one large stone and a small eraser, both of them dropped from certain height simultaneously. So here the stone and the eraser reach the surface almost at the same time. We consider both of having same mass. Next, in second experiment, we take a small eraser and a sheet of paper, drop them simultaneously from the same height. Here the eraser reaches the ground first and the sheet of paper reaches the ground. Okay friends, right? So when the eraser and the paper dropped from certain height, means here the eraser reaches the ground at first, then the paper reaches the ground. Okay students, next from the third experiment, we take two sheets of paper having same mass and one sheet of paper crumpled into a ball. Now drop the sheet and the ball from same height. You can observe that the paper crumpled into a ball reaches the ground first and the plain sheet of paper reaches later. Students, although they have equal mass, the ball shaped paper reaches the ground at first, then a plane of sheet. Students, do you know the reason for this? Why the ball shaped paper reached to the ground first? Students, you need to understand that Here the magnitude of the air resistance when it is dropped in air medium at a certain height, the magnitude of air resistance depends on the area of the object exposed to air. So, the area of the air resistance exposed on the plain sheet of the paper is greater than the area of air resistance exposed on the ball shaped paper. So only the ball shaped paper reaches the ground first, then the plain sheet reaches the ground, because the area of air resistance exposed on the plane of sheet is greater, so only it will take some time than the ball shaped paper. Okay students, so from this concept here we take, when the objects are dropped in the absence of air medium, all would have reached the ground at the same time. But in air medium, air offers some resistance due to the air offers some resistance to the motion of the freely falling object. Here that ball shaped paper reached the ground first, then the plane sheet reached to the earth later. So here we consider the resistance offered by the air medium. It is negligibly small when compared to the gravitational pull acting on the stone and rubber. Hence, they reach the ground at the same time. In the first experiment, the stone and the eraser both have reached to the ground at the same time, because here the air resistance acting on the stone and the eraser, it is very much smaller compared with the gravitational force acting on them. So it is negligible. But in the plain sheet of the paper, the air resistance offered by the air medium is greater. Okay students, so like this, here the air resistance is removed. Like when the object is dropped in vacuum, means there is experience a acceleration of the object is independent of mass, Okay, so like this here, this means that all objects having the shape hollow or solid, big or small, should fall at the same rate, that is called free fall. Okay, so all the object is accelerated due to acceleration due to gravity. All the object accelerated due to acceleration due to gravity. So all the object should fall at the same rate, that motion is called free fall. Students, I hope that you understood well. So for the freely falling body, the equation of motion can be obtained by replacing A with G. In that equation, the acceleration is noted by, in the equations of motion, the acceleration is noted by letter A. Here the acceleration due to gravity for the freely falling body, it is due to the acceleration due to gravity. So the letter A is replaced by G. So for a freely falling body which is initially at rest, so the initial velocity u is equal to 0. Thus we get the following equation. What is the first equation? V is equal to u plus at. That is a first equation of motion. Now that equation is replaced for the freely falling body. V is equal to u is equal to 0. So v is equal to 0 plus at is changed to gt, because the acceleration of the body is replaced by the acceleration due to gravity. So v is equal to gt. This is a first equation of motion for the freely falling body. So next equation. So in the equation of motion, what is the next equation? S is equal to ut plus half at square, ut plus half at square. So for the freely falling body, u is equal to 0. So S is equal to 0 plus 1 divided by 2. Replace a by g, so gt square. This is the second equation of motion for the freely falling body. So what is the third equation of motion? That is v square is equal to u square plus 2as. Already we know that for the freely falling body, initial velocity u is equal to 0. So the third equation is modified to v square is equal to 0 plus 2 GH. 2AS is replaced to 2GA. A means that is acceleration due to gravity, so that is G. Next S means that is a displacement. Displacement means that is height of the object, so H. So V square is equal to 2GH. It is a third equation of motion for the freely falling body. Okay students, so when we throw an object vertically upwards, it moves against the acceleration due to gravity. Hence, the acceleration due to gravity A is taken to be minus G. Okay, it is opposite to the acceleration due to gravity. So, the letter A is replaced by minus G. And then, when the object is moving downwards, here the acceleration of the body is depends upon the acceleration due to gravity. So, the letter A is replaced by plus G. Okay, students. Thank you very much.